Hi YouTube and welcome back to the channel. In this week's video, I'm going to talk to you specifically about high-churn tables in Snowflake. We're going to cover what they are and how they can impact cost and performance within your environment. We'll do a little bit of a primer around micro-partitions and query pruning and why that's super important, certainly for the larger tables that you get in your Snowflake environment. We'll cover then how these performance and cost issues manifest themselves and how you can identify them. And finally, at the end of the video, we'll conclude with a pattern to help you navigate these challenges in your own environment. So I hope you find it useful. Okay, so first up, we're going to start with a little revision around micro-partitions. So what are these? So when you load data into Snowflake, micro-partitions are created on the underlying cloud storage area. These are small blocks of storage between 50 and 500 meg uncompressed. And when loading data into Snowflake, there's a few things that happen behind the scenes that Snowflake takes care of that you won't necessarily see. The first one is data is divided and mapped across multiple micro-partitions. Now, bearing in mind the relatively small size of these micro-partitions, for a very large table, it could have millions and millions of micro-partitions. And we'll come back to why that's important for Snowflake and for performance in the next part of this chat. The next thing it does is it compresses and encrypts data. So it compresses data into Snowflake's native compressed format, allowing Snowflake to store more data in a columnar way and retrieve that data really quickly. And that's how it gets its performance. It also encrypts data, so everything by default in Snowflake at rest and in transit within the Snowflake environment is encrypted by default, and you can't turn that on or off. Finally, some metadata is captured as part of that process, and that essentially is stored because it needs to tell the query optimizer in Snowflake which micro-partitions store which data. So when the queries appear in the future, it knows exactly where to go to get that data, and that's what we're going to cover next. So that particular process is known as query pruning. Now, here's our user running a query in Snowflake or running a dashboard or working with an application where the data is stored in Snowflake. Here's the table, and within that table, we've got several micro-partitions storing the data for that table. And for this particular query, we may have the data on micro-partition 2 and 3. And so we don't want Snowflake to go off and read through all of these different micro-partitions when we need just these two to be run, because that's how we get better performance and cost optimization. So what the query optimizer does is it leverages that metadata it's captured when data is loaded into Snowflake. Now, when data is loaded into Snowflake and placed on these micro-partitions, it's loaded in the order that the data is loaded. And typically that might be by order date or sale date, for example. And in that case, then it'll be naturally ordered across these micro-partitions, which is absolutely fantastic if lots of your queries are based upon date predicates, because that will work really well. However, when you want a query of customer ID or count ID, that may not necessarily work in the best way because your data is not ordered in that way across micro-partitions. So we'll come back to that point in a second, but when this query is executed, we look at the metadata in Snowflake, or the query optimizer does. It produces a query plan to provide the fastest access to that data so it can return it without necessarily reading through all these micro-partitions. Now you can consider this and compare it to finding something in a book, a physical book. If you want to find something in particular, you could flick through all of the pages and try to find that, which would be the equivalent of Snowflake going through all these micro-partitions and carrying out full table scans. It's not that efficient. You might get lucky, but invariably that's going to take a lot longer. You could turn to the contents page, the table of contents, or the index to really help you work out what pages the data that is relevant to you is on. That's exactly the kind of scenario that we can apply to this process in Snowflake, where it uses the micro-partition metadata in the same way as you would use a book's index to really refine and target where this is. That process, really important, is called query pruning, and it means that we're only looking for the data in the place where it's going to live. Now, I mentioned just before, what if your queries, the majority of your queries, are against a different order to how the data comes in? So if your data's coming in on order date and you want to use customer ID, how best can you order or influence that order structure of the data across your micro partitions so you get the maximum benefit? Well, you can order data then on the way in. It will add a small overhead to that initial write, but then all of your reads then can take advantage of that ordering. Now imagine this table is a really high churn table, and what I mean by that, it's getting a lot of inserts, updates and deletes. That means that all of your micro partitions are being rewritten quite a lot of times. So effectively remember that an update is effectively a delete followed by an insert. And so we're creating new micro partitions, and then Snowflake will come along and remove deleted rows at a later point in time. So these can get out of order quite quickly because we're adding new micro partitions. There's lots of churn, lots of volatility in terms of that data changing, which means the natural ordering of your micro partitions are all impacted, and it can break down over time. And for very large tables, which are experiencing high volatility and high churn, that can start to impact cost and performance. In addition to that, these changes that you're making against the table, depending on your options and configurations in Snowflake, which we're going to cover next, these changes can all fall into the life cycle of the continuous data protection mechanism that runs in the background within Snowflake. So let's take a look at that next, because that can really impact cost. So CDP, continuous data protection. If you're not sure what that is in Snowflake, essentially you've got your current storage. So this is the data online and available in your tables to query right here and now. If you then change that data or delete that data, it can be then stored in time travel, and that can be anything from 0 to 1 to 90 days. And once it reaches the end of its time travel period, it then ends up in this failsafe area, which is for permanent tables 7 days, and for transient tables it is 0. Now all of these copies of the data changes that you've made take up space, which you then pay for in terms of storage costs. So every single time you're making a change, so a huge table, that then is fallen into this life cycle, taking up storage. And we'll look at a quick example of this now. And to give you a good indication of the impact on costs that this may be attributed to this life cycle, we're looking at an extreme example. So we'll look at a table here, 200 gigabytes in total. But let's say we get a lot of changes and every row is updated 20 times every single day. Obviously it's an extreme example, but it does demonstrate the impact of cost. So 200 gigabytes, each one of these records is changed 20 times a day. That equals 4 terabytes of data going into your time travel, because every version of every record is in there 20 times. That ends up in failsafe, which is coming out at 28 terabytes. That totals 32.2 terabytes in total that you're paying for because of this. So that high churn table really in this situation is incurring overly excessive costs. Now part of the solution is to create these tables as a transient table with a 0 time travel retention period. So that's a parameter, data retention time and days, that you can set at a global account level, at individual table schema level. And then you could actually bring in your high volatility changes, which we'll see in the deferred merge pattern next, into this transient table to prevent these changes going into time travel and failsafe. But you're still capturing the changes, you're still making them available to end users, but it gives you a greater degree of flexibility of when then you want to push these changes into your target permanent table for real, and it allows you then to manage that. So what does that look like? So let's say these 20 times of changes on every row every day, we're going to direct that to a transient table instead. And I'll get into more detail what that looks like for real in the next page I've got. And then we can push those changes into our target table in a control basis, let's say once a day. So every record now of our 200 gigabytes is just changing once a day. That means we get 200 gigabytes going into time travel. And that means we end up with 1.4 terabytes in failsafe, which is a total of 1.8 terabytes. So quite significant. Just a high level, simple example, different extremes to give you an indication of the impact on cost in some of those areas that you certainly should be considering if you or your Snowflake environment has these characteristics. Moving on to the deferred merge pattern. So how can we actually address this? So this pattern tries to bring together some of the points we've discussed so far to help make it more efficient in terms of preventing those changes going into the CDP lifecycle, as well as maintaining our ordering across micro-partitions so it doesn't degrade over time. Now the first aspect of this is the permanent table. This is going to be our permanent, let's say, massive dimension table with lots of churn. And in here, this is what we're going to be terming as cold data. This is the data that we want to keep online, make it available to our users over a longer period of time. And this is going to have that data going into the CDP lifecycle because we do want to have an element of coverage in terms of time travel and failsafe because this is business critical data for us. We've next got a transient table here. This is hot data. So this is receiving our changes throughout the day. In the previous example, these are 20 different changes throughout the day, intraday changes coming into here. This has a time retention period, so retention equal to 0 days. So that means then when we're storing data behind the scenes as well in time travel. We have a stream here, so in Snowflake, let's say we've got a table. Further upstream, we're capturing changes from that. And it could be more complex, it could be multiple streams. Let's say in the simplest solution, this we're expecting just inserts only and an append only. We can even change the stream to have it append only criteria on there. So we're just capturing the additional rows coming in. And we can use that as our source then to push this data into our transient hot data table throughout the day. And then we've got a view. So this is where our users come in. They get pushed to the view. The view combines the data from the permanent cold data table and the transient hot data table together. So users still have the benefit of being able to see all of the records in one place. They're not exposed to this level of complexity at all. And we can also see intraday changes in there. And then periodically at the end of every 24-hour period, we've got a process that runs to merge this hot data into the cold data table, at which point we truncate and remove the records out of this table to keep it clean. And I'll come to some of the considerations around this as you get more complex scenarios such as inserts, updates, and deletes in SED type 2s in a second. But that is essentially the deferred merge pattern in Snowflake and how it works. So no doubt now with this, you're beginning to understand that this pattern really helps provide greater flexibility to control high churn table processing whilst overcoming some of the challenges we mentioned earlier in this video. So the hot data table, the transient table then minimizes those data changes entering the CDP lifecycle. That helps to keep controls around storage costs. And as we periodically move data into the permanent table, into the cold data, that provides us with an additional opportunity to order data on the way in here to preserve the effectiveness of our micro-partitions. Now this does get more complex when you need to cater for inserts, updates, and deletes, of course, and that means you'll need to consider the logic in the view first of all to work out what changes you need to surface to the end users. When you're merging changes from hot to cold, so the obvious choice would be for you to use a merge statement, but that doesn't really allow you the flexibility to order records on the way in. So you might want to split out that process into a two-step operation, one to process inserts and another to process updates. Anyway, I hope you found that video useful. I hope it all makes sense to you. Let me know in the comments if you try this approach and how it works for you, if there's anything I've missed. Also, let me know if you take a different approach and adopt that for your own environment. Hope you found that useful. If you did, keep watching, keep subscribing. New videos coming very soon. Hey, it's Adam here, and I just want to jump in real quick and just give you the latest information on the Mastering Snowflake program. It's now in its third year and it's doing really well, and there's more people than ever showing interest and joining the program every single day. as we enter the new year of 2024. And this has been designed really for people who are quite experienced working as an IT data professional. Most of the members on the program have between 10 and 15 years experience working with commercial databases. They're very comfortable with SQL and all of the different terminology that goes with data warehousing and running databases at an enterprise scale. And so these people, they might have scratched the surface of Snowflake. It may have intrigued them. They may have no knowledge of Snowflake, but a lot of sort of Teradata, SQL Server, Oracle on-premises experience. And they want to know, crucially, how do they leverage all of that time and money that they've invested to get to the point in their careers they are today and leverage it for the cloud with Snowflake. So I designed the program exactly for those kind of people because back in 2017, when I first got my hands on Snowflake, I was in a very similar position. I had to learn through trial and error, testing out what worked, testing out what didn't work, and then coming up with a set of recipes that really worked in Snowflake to address common real-world challenges. And so once I had those, I packaged those up and put them into this program. And this program's certainly not about theory. Of course, I introduced what the technology and capabilities of Snowflake does, but crucially, I tell you how you can package up Snowflake's out-of-the-box capabilities to address real-world challenges. I run through with live demos. I provide you with my code, assets, and templates to download and use within your own environments or use as a starting point to customize further. You'll get access to my Everest guide to help solidify some of the knowledge that you're gonna be recipient of during the program as well. So, three different kind of areas to the program itself. One is the on-demand training portal available 24/7 with all those downloadable assets on. It's all video content produced by myself, so you know who's delivering that. You know what the learning style is going to be like from watching these kind of YouTube videos. It's going to be direct, it's going to be to the point, and it's going to be enabling you get the maximum value for yourself, your career, and your organizations that you're working for or working with. You'll also, as a member of the program, get access to the private members only LinkedIn group. All our members globally who join the program get access to this. It allows you to ask any questions around the course, around Snowflake. That could range from interview, question and answer guidance through to other tooling, such as Matillion, DBT, Elation, Power BI, you name it. You can ask the question there and I will help you to the best degree I can. But of course, I don't know everything. The other members then can also join in that conversation and share their own unique set of experiences because everybody's on this journey together. Further to that, there's a weekly 60-minute group consultancy call, again hosted by myself. You can come in and it's a different vehicle for you to ask questions and get guidance and support. Different vehicle than the LinkedIn group. It provides live real-time feedback. Finally, it's a one-off investment to join the program, but once you're in, you are in for life and you will not pay a single cent or penny more to get access to all future updates to the program. And the great thing is we can drop things into the program as and when we see fit based upon members' feedback or based upon new features and services Snowflake are releasing to the market, which is very frequently, if you don't know, Snowflake release new features every single month to the market. So we'll apply a lens to that and work out what's publicly available to Snowflake customers and what's going to be most impactful for our members to learn. At this point, you may be aware that I've authored a couple of books on Snowflake as well. And so you get the chance to work with me and help build this community out. In the program, we cover 10 modules. Within each module, there are a series of lessons going into real depth in each one, and we get to an advanced level of knowledge. So we try to cover everything possible from a capability perspective within Snowflake. The Snowflake lessons are continually evolving, as I mentioned, as Snowflake grows and evolves as a product as well. And a great example of that is Module 10, Developing Applications in Snowflake. We've recently added native application demos in there, so you know how actually to package up and create your own native applications. We've also got Streamlit lessons in there where we hook into the OpenAI API and actually query large language models in Snowflake. We also hook into the Snowpark API and work with Snowflake. as part of those lessons. So loads of value, loads of great feedback. Here's all the lessons, loads of great feedback from various valued members who are also part of the program, because as I mentioned, once you join, you're in there and you continually get value from that, and it follows you as you and your career grows. Some of the people that joined at the outset 3.5 years ago still have access and still get continual value today. I hope you find that useful. If you want to apply, it's invitation only, and I review all applications personally. So have a look in the link in the video description, and I'd be really pleased to welcome your application to the program.